Not. All right, thanks so much for having us. Some of you have seen this paper. You all know, like, I disastrously run over time. I tried to cut the slides so that I don't. So Tony, please, like, give me hand signals or whatever so that I stop. So what we're interested in this paper is to think about the interaction, the two-way interaction between what we call credit market sentiments and economic cycles. And I will be very clear about all of these, what I mean by any of these expressions. What we all agree on is that economies are subject to cycles. By a cycle, I mean two bulks of events happening back to back. The first kind of bulk is what we call good times. Good times is usually associated with abundant credit at small spreads, even to risky firms, as well as, unfortunately, deterioration of credit quality. This we are going to call high credit market sentiments, or we know them as overheated markets. Usually, this is accompanied by high output and positive output growth in the real economy. Then this bulk of time is followed by bad times in which risky firms are squeezed and credit is expensive if there is any, and even good firms are affected. On the other hand, issued credit is of higher quality usually. And this we're going to call low credit market sentiments. Moreover, during this time, usually the output is low and the output growth is negative. So what we're interested in this paper is to think about specifically what predictably triggers periods of credit market overheating, transition into recession, lengths of booms and recessions, and things similar to that. Furthermore, we're interested to understand whether the economy which arises, that dynamic economy that arises, is constraint efficient, and if it is not, what is the cost and benefits of different policy instruments. So before jumping into the model, this is going to be a theoretical model. So let me give you an overview of what you should expect. So when I say sentiments throughout the talk, I mean the choice of lending standards. And this will clearly be endogenous in our model. Endogenous in our model. However, this is a rational model. So when you think about sentiments, you usually think about behavioral sentiments. Here we use sentiments as a completely rational object, okay? And we focus on this two-way interaction between sentiments and real outcomes. So this circle, it's a square, but it very clearly says what is going to happen in our model. So imagine we're in a state where there is lax lending standards. Okay, so credit is very heavily available. So both the credit micro and real economy booms. But at the same time, that leads to a deterioration of fundamentals. Once the fundamentals deteriorate enough, then lenders are like, oh my God, why are we using such lax standards? So let's switch to tight standards. Once they switch to tight standards, then there is both a credit market and real downturn. But however, the fundamentals are going to improve. And once the fundamentals have improved enough, then lenders are like, oh my God, why are we giving up on so many good projects? So let's switch to lax lending standards. And then the cycle continues. So this leads to endogenous cycles. So I want to be very clear that there's zero exogenous shocks in this model. Zero TFP shock, nothing, okay? And at the same time, we do not think that exogenous shocks or productivity shocks don't happen in the real world. They do happen, and you can augment this model with all of those, but we are interested in what predictably triggers cycles, because policy can affect what is predictably triggering cycles, and so that's why we're interested in generating endogenous cycles without any exogenous shock. It turns out that cycles are actually quite rich in this model. They have various boom and bust lengths. We can have double dip recessions, and some of them I will talk about throughout. And then at the end, when I talk about policy, I want to focus on comparing two particular policies: macroprudential policy and monetary policy. Now, let me actually jump into the model. So the model is relatively simple. There is one good, there is infinite time. This is discrete time, so time 0 to infinity. Each day is divided between morning and evening. There are two types of agents. There are entrepreneurs who produce and investors who provide funding. Every single agent is risk neutral. Each of them receive 1 unit of endowment, both entrepreneurs and investors. They can save at rate 1 plus RF. Think about RF as some storage technology within the period, so from morning to evening, but no saving overnight. Okay. So for the purpose of this talk, before we get to policy, you can normalize RF to 0 if you want. Okay, but it doesn't matter. You can also assume it's positive. Now let's think about our first set of agents, who are the entrepreneurs. Importantly, entrepreneurs have a two-dimensional type. They're either good or bad, which I will tell you what good or bad means. You don't know yet. That I'm going to denote by tau. And then they're transparent or opaque, which is something about information. I'll tell you what that is too. And that we denote by omega. Now, let mu at each time t denote the measure of bad entrepreneurs, the total of them. So both bad transparent plus bad opaque. Okay. And so this means there are this two-dimensional type. Means there are like 4 types of entrepreneurs in the economy. There are good transparent, good opaque, bad transparent, and bad opaque. Okay. And I want to argue for you that the state variable of this economy is the distribution of entrepreneurs. In particular, it's given the dynamics of the model, it turns out that the state variable is actually two-dimensional at most. So keeping track of fraction of bad opaque and bad transparent entrepreneurs is sufficient. And in fact, in the whole talk, except 1 slide or 2 slides, I'm going to focus on a particular case where only 1 state variable is relevant. Okay, it's an endogenous thing, so there's parameter restrictions under which only 1 state variable is relevant. That is the fraction of bad opaque entrepreneurs, and that is what is in red here. So let me try to bring out my yes. Okay, so I'm going to focus on the case where the only state variable of the economy is the fraction of bad opaque entrepreneurs at time t. So remember, bad is mu and opaque is 0. Okay, so mu 0t is the fraction of bad opaque entrepreneurs at time t. Mu 1t is the fraction of bad transparent entrepreneurs at time t. And you have to accept from me that the remainder of entrepreneurs, given the dynamics, are going to be half and half transparent and opaque. So the fraction of good opaque and good transparent are equal. Okay, so just accept it from me. Now let's think about the dynamics of entrepreneur type distribution. This is a stochastic OLG model. Each entrepreneur is replaced by a newborn under 2 circumstances. They can die exogenously with probability delta. Any entrepreneur might die. Or, and this is an assumption, if an entrepreneur is not granted credit, it is going to die. Okay, it's going to live that period, but then it's going to die. Okay. And then the replacement happens with somebody from the outside distribution. The outside distribution have lambda fraction of entrepreneurs bad, 1 minus lambda good, and then half opaque and half transparent, and this joint type distribution is IID. So this, given that entrepreneurs are replaced if they're not granted credit, that means the entrepreneur type distribution is endogenously determined by credit market outcomes, because credit market outcome determines who gets credit and who does not. Okay. And so that means that the 2 things that I said are state variables. The fraction of bad opaque entrepreneurs and bad transparent entrepreneurs are endogenous and time varying. Now, let's finish the discussion of entrepreneurs by talking about their technology. Their technology is extremely simple. Each entrepreneur has to choose an investment level, I, which depends on its type, and it's going to have a linear technology. Furthermore, it obtains credit, which we're going to denote by L, at an interest rate R, which is going to be dependent on its type, and its two-dimensional type, and it's going to determine an equilibrium. Now, each unit of investment I costs 1 unit. There are 2 ways to cover it. It's either covered by the entrepreneurs or endowment of 1, or by credit. Okay, so that's super simple. Then this investment, which is done at in the morning, in the evening, it returns rho. Rho is greater than 1 plus the storage technology rate. So for the purpose of this talk, I'm going to assume that rho is the same between good and bad entrepreneurs. You can assume it's different. In particular, return of good entrepreneurs is higher, and that we have it in the appendix, but the calculations are just going to be so much more complicated, so we assume it's equal. Then, importantly, credit is collateralized, and it has to be collateralized by the investment. What does that mean? That means the amount of payback for the credit, which is 1 plus R times L, have to be covered by the investment. What that implies is that financing each unit of investment requires R down payment. Okay, so each agent to borrow 1 unit, it has to give R unit as down payment. Okay, so what does that imply? That means an entrepreneur who faces a higher interest rate, it can borrow less. Okay, that's very simple and straightforward. Now that takes us to the first friction of the model. The model has 2 frictions. I'll get to the second one, and that's about information. So the first friction is that bad collateral is not seizable. Okay, so that means bad entrepreneurs do not pay back. Okay, so that's very simple. That means it's important to know who is a bad entrepreneur, which then will lead us to the second friction, which is information asymmetry. Now let's talk about the investors, and through them to the information asymmetry. Each investor lives 1 period, and it's replaced by the same exact type next day. Investors are 2 types. There is a small measure of skilled investor. Remember, each agent, including each investor, has wealth 1. So the measure of investors is also their wealth. So the wealth of skilled investors, or their measure, is small w1. What does skilled means? Skilled means a skilled investor exactly knows what is the type of the project or entrepreneur. I'm gonna interchangeably use type of project or type of entrepreneur. Okay, so each investor, he observes a project, he knows both tau and omega, both transparency and good or bad. Then there's a large measure of unskilled investors of total wealth W0. And here is where information asymmetry comes in. They don't know the type of the project. They only observe an imperfect signal on a sample of loan applications that it submits. Now, the key is that these signals are generated by a test, and investors choose which tests they want to run. They can choose between 2 tests. Either test that they choose, they have to pay a cost C for it. And this is really, really the key to the model. So if you understand this, you understand the rest of it. So there are 2 types of tests. There's a bold test and there's a cautious test. Okay. A bold test is a test which have false positive mistakes. Okay. What does that mean? It means any project which is good, whether it's opaque or transparent, it says it's good. However, it pools bad opaque projects with good projects. So it's false positive. It says some bad projects are good, and these mistakes are all concentrated on opaque projects. So this is, in a sense, think about it, this is a test which says, okay, I don't want to give up on any good investment. However, at the cost of sometimes I'm going to finance some bad investment. That's why we call it bold. The other case is a cautious test. This cautious test has false negative mistakes. What does it mean? Any project that is bad, it can identify it as bad. However, it identifies unfortunately, the opaque good projects also as bad. Okay, so it gives false negative mistakes. So some good projects, it's going to pull them with bad. This is cautious in the sense that it is, okay, I don't want to finance any bad investments. Okay, maybe I give up on some good investments. Okay, so what's important is that the degree of information asymmetry by both tests is the same. It's just the type of mistake that they make is different. It's not that someone is better than or worse informed than the other. Okay, now let's move to the credit market. First, let me start with the main friction. As I mentioned already, the main friction is that bad entrepreneurs do not pay back, so it's important to know them. However, a big fraction of investors only have imperfect information on the type. Now, the mechanics of the credit market is pretty complicated. I don't want to spend time on it. For people who are interested, it's like Scheimer-Guerrieri adverse selection random search market. Okay, so what happens is that each investor advertises an interest rate R tilde. Each unskilled investor picks a test, and each entrepreneur submits credit demand to different interest rates. Okay, and then whenever there is like an entrepreneur and investors, they have to be matched, and then the credit is raised. Now, let's first start from the stage game equilibrium. I'll walk you through the stage game equilibrium and then put dynamics on top of it. And the stage game equilibrium consists of a very, very key intermediate result, which I'm going to try to give you some intuition about it. The key result is that investors choose bold tests if and only if the fraction of bad opaque entrepreneurs is low. Okay. The trade-off is relatively simple once you stand back and think about it. Here is the trade-off. Bold test means lax lending standards. So there is more lending because more people pass the test. However, some borrowers are bad and they don't pay back, so they default. And then the default, so that means the defaults are higher when the fraction of bad opaque entrepreneurs who are the ones who do get this credit by mistake is high. That means when this fraction is, and that is the length that is the rate that basically every entrepreneur has to be financed at. So that means conscious investors can offer lower interest rate than bold investors when the fraction of bad opaque entrepreneurs is high. Okay, and that leads to this key intermediate result that I mentioned. There is an endogenous threshold, which you can exactly characterize. It's the cost of the test divided by 1 plus RF. If the fraction of bad opaque entrepreneurs is less than this threshold, then all investors choose the bold test. If the fraction is above, then all investors choose the cautious test. Okay, since all the investors are gonna behave the same, we're gonna call this bold stage versus cautious stage. So let me step back 1 second here and say this is where I am only focusing on one case of the model. Okay, and this is where we call what we call a two-stage economy in the model. The talk will be focused on a two-stage economy, except one slide where I will also walk you through what's called a three-stage economy. So every cycle in the model is either two-stage or three-stage. And for the purpose of this talk, let's ignore the three-stage and only focus on the two-stage. So if the fraction of bad opaque entrepreneurs is small, then everybody chooses to be bold, okay, because there are few defaults, and that's called bold stage. If the fraction of bad opaque entrepreneurs is large, that's the last line, then defaults are high, so everybody chooses the cautious test because they want to prevent defaults, okay? Now, what happens in the bold stage is that bold investors lend to all the good entrepreneurs and some bad ones, the ones which are opaque. That means investment is high and output is high. Furthermore, and this is an endogenous outcome of the model, but you can show it. We show it also in a different paper, and this is this relies on this paper in Econometrica by Pablo Kula. Okay, all entrepreneurs raise funding at a common interest rate. So in the So in the bold stage, there's only one interest rate. However, the loan quality is low, and that you can already see because all good and some bad entrepreneurs get credit. So that means loan quality is low. And this is associated with the booming economy, but I would call it overheated credit market. In the cautious state, investors lend to good, transparent firms only, okay? And this is most of the investors, which are, so actually I should say here, unskilled investors. Unskilled investors only lend to good, transparent entrepreneurs because they choose cautious tests. They cannot tell apart who is a good, opaque entrepreneur. So the good, opaque entrepreneurs are constrained by the scarce capital of the skilled investors. So this already tells you why I made these assumptions. So I want the capital of skilled investors to be in short supply, okay, because that leads to a high interest rate, okay? So, and then that also leads to a low output. Furthermore, there is no bad credit because the cautious test rules out all the bad projects. Skilled people know all the bad projects, so there's no bad credit. That means investment output is low. There is a credit spread. So there is dispersion in interest rate between what good transparent firms raise at and what good opaque firms raise at. However, loan quality is high because there is no bad credit, okay? And this we call low credit market sentiments. And now we can move to equilibrium dynamics. Dynamics, as I said, I'm going to focus on a two-stage economy in which the only state variable is the fraction of opaque bad entrepreneurs. So the dynamics is the law of motion for these guys. So remember, the law of motion is determined by some exogenous death rate plus credit market conditions, if they get funding or not. In the cautious states, bad entrepreneurs die at a higher rate because they die exogenously and they don't get credit, okay? That means in a hypothetical steady state where investors, we can think about comparing two hypothetical steady states, one in which investors choose cautious tests, and one in which investors choose both tests. If comparing those hypothetical steady states, the fraction of bad opaque entrepreneurs in cautious steady state is lower than the fraction of bad opaque entrepreneurs in the bold steady state, because in the bold steady state, some of them are financed. But remember, I told you the key result here that investors choose bold tests if and only if there is few bad entrepreneurs, okay? So there is a threshold, okay? If mu0 is here, mu0t, then the investors choose the bold test, and that means the number of bad projects goes up. And if the fraction of bad opaque project is above the threshold, then investors choose the cautious test. So that fully characterizes the dynamics. So let me show you the first dynamic picture. It's a lot easier than going through the proof. On the x-axis is time once we've reached the ergodic stage. On the y-axis is the fraction of bad opaque entrepreneurs, which is the state variable of the economy. So I'm plotting the evolution of the state variable of the economy. And I have the two exact things that I talked about in the last slide here. So the green line is the fraction of bad opaque entrepreneurs in a hypothetical steady state where every investor is cautious, and that's low because basically bad entrepreneurs never get financing. The red line is the fraction of bad opaque entrepreneurs in a hypothetical steady state where every investor is bold, and that's high because some bad entrepreneurs get financing. The purple line is the threshold of switching. So if we start from a point, from a state variable which is below the threshold, so this is a fraction of entrepreneurs. This is a distribution of entrepreneurs where there are few bad opaque entrepreneurs. So all investors are bold. So the fraction of bad opaque go toward the attraction point mu bar B. Okay, but before reaching mu bar B, they're going to reach the threshold. Okay, and when they reach the threshold, all the investors endogenously choose to become cautious, and when they become cautious, bad entrepreneurs don't get financing. So the fraction of bad entrepreneurs fall. Okay, and then the cycle continues. Now you can draw the output growth. Okay, for the same exact picture, you can see throughout the period where the state is, when we are in the bold stage, the output growth is positive. Okay, so you can think about it as a boom, as a prolonged boom. While we go to the cautious state, it's like a bust, so the output growth becomes negative. In terms of the interest rate credit market, throughout the boom, there is one single interest rate. And then when we go to the bust or cautious state, there are two different, there is dispersion in interest rates. Now, it turns out that this is not the only type of cycle that the model can generate. The model, depending on the parameter, has three major classes of cycles. One is a normal expansion and contraction, second, prolonged recovery, and third, double dip recessions. So normal expansion and contraction is exactly what I told you. There is a long expansion, okay, in which the output growth is high, although it's falling, and there is a short contraction. There can be prolonged recoveries. So prolonged recovery means a cautious stage which is long, okay? So you can see, I mean, these lines are very close. Sorry, this is a very particular set of parameters. So while the state variable is above the pink line, which is here, I don't know if you see it or not, so this is a pink line right above the green line, then the economy is in cautious state and the output growth is negative, although it's increasing. When it crosses and goes below between the pink and green line, I have to magnify this picture, sorry, this sucks, then then everybody becomes bold. And when they become bold, that means the fraction of bad entrepreneurs grow. So they then at that point, the output growth is positive, but then the economy, the investors again switch to being cautious. Lastly, there can be double dip recessions, and that is the case that I don't want to walk you through because it's kind of complicated. Then in that case, in this stage, everybody is bold. In this little one, everybody is cautious. There is an intermediate stage. That's what we call it, the three-stage economy, in which, as you would expect, a fraction of skilled investors are bold and a fraction are cautious. Okay, so there is dispersion. However, because a fraction are bold, still the fraction of bad entrepreneurs are increasing. So this is the case. This is the case where in this region of mixed economy, the fraction of bad entrepreneurs are high, but it's not sufficiently high that everybody becomes cautious. So the output growth becomes negative, but it still keeps falling until it becomes so bad that it rises. Okay, so finally, let me very quickly talk about the optimal policy. Think about a constraint planner, which can choose a threshold on the state variable for which above that threshold, investors choose the cautious test, below the bold test. Okay, so it basically can change the bold cautious threshold, which was C divided by 1 plus RF. It turns out that the constraint optimal outcome is often cyclical. In particular, it depends on the parameters. If the fraction of newborn bad entrepreneurs is intermediate, so lambda is not too high, not too low, and there is enough persistence so that the death rate is not too high. Okay. However, what's important is that the equilibrium is not constraint efficient. And the reason is that in this model, cautious state keeps the fraction of bad projects at bay. So once the economy switches to cautious state, basically the good project, the fraction of good projects grow, okay? And so the economy becomes better in a sense. So in a sense, having cautious stages every once in a while makes the booms more welfare enhancing. Okay, so cautious states are, in a sense, busts are bad, but they're not horrible because they have a purifying effect. They keep the fraction of bad projects at bay. And investors don't internalize their effect on the evolution, and that's where the inefficiency comes from. So we can think about three different policies. One is a simple monetary policy in which the government chooses an interest rate RF over time always, and under that investors choose what test they want to use. Second, there's a counter-cyclical monetary policy, a government who can calculate the aggregate state. So this is a smart government who can run the equilibrium and calculate the aggregate state. It chooses zero interest rate in cautious state and a positive interest rate on the bold state. Third, this is a macroprudential policy in which there is a capital requirement exposed for investing in risky loans. What is a risky loan? Risky loan is a loan which is issued by a bold test, because cautious test only leads to loan to good good entrepreneurs, so it's not risky. Now the question is, how do they rank? And this is how they rank. So on the x-axis is the planner threshold that I talked about. Okay, this is the switching threshold that the planner would choose. This is the last slide. And on the y-axis is the mean welfare associated with the planner, equilibrium, and the three policies. The equilibrium is the blue line. So you can see that the threshold that equilibrium chooses for these parameters is between 0.3 and 0.35. The green line is the welfare of planner if he chooses different thresholds. You can see that the planner wants the threshold to be lower. This is where it's maximized, okay? And the three lines are the three colored line in the middle is the three policies. The pink is the counter-cyclical monetary policy. The blue is capital requirement. The orange is the simple monetary policy. First, you can see that basically they do not reach the planner. Okay. Second, you can see that the simple monetary policy sucks. It often falls below the equilibrium. Third, you can see that at the optimum, when the capital requirement and counter-cyclical monetary policy are maximizing welfare, they're actually very close. So the counter-cyclical monetary policy is a little better, but I want you to pay attention that the counter-cyclical monetary policy requires a very smart government who can condition on the aggregate state, because aggregate state of this economy is not exogenous, it's endogenous. However, the capital requirement is only individual specific. It requires a capital you to hold capital if you choose a bold test. It turns out that in equilibrium, that also talks to the aggregate state, but the government does not need to know the aggregate state. So let me finish here. Thank you.